So we already saw how to handle files, copy them, move them, rename them, etc. And we also saw that some of the commands allow you to handle different files on the same time. So the shell does offer some wildcards, special characters that allow you to rapidly specify groups of file name to avoid typing the different names. It's easy when it comes to handling 2, 3, or 4 files, but when you are handling 100 of files or more, it's much easier to use the wildcards, of course, and avoid writing 100 of file names. So the wildcards are a group of special characters that allow you to select file names based on a given pattern of characters. Here are some examples of the most used wildcards. The star, for example, stands for any character. It can be one single character, and it can be as many characters as it finds. So basically, if you hit CP star, it's going to refer to all the file names that you have in your directory, for example. So star matches as many character as possible, and any type of character as well. The question mark matches any single character. It's just one character, and but it can be any character. If you specify the exclamation mark followed by characters, it matches any character that is not member of the set of characters that you just specified. If you specify a set of characters, this would mean that the pattern you are looking for needs to match any character that is a member of this set. And the set of character can also be specified as a POSIX character class, such as in the following examples. You can, for example, decide that you want to deal only with digital characters, which mean only the numeric characters. You can specify that you want only digits. You can also specify that you only want alphabetic characters, upper, lower, alphanumeric characters, etc. Here are some examples of the use of wildcards. If we use, for example, A followed by star, this will mean that we are looking for any file name, any pattern that is starting with A followed by any other string, which means that the file name can be simply A, and it can also be anything starting by A. If you use simply star, this will mean that it's going to consider all the possible file names. Like the most dangerous command would be rm star, and it's going to delete the content of all the content of your current working directory. So star basically uses all the possible file names. So be very careful with that. If you type, for example, capital A followed by star and then .fasta, this will mean that it's going to look for all file names that begin with capital A and that end with .fasta. Here for Cygwin and for some Mac terminals, you won't see the difference between, it's not case sensitive, but the basic Linux is case sensitive. If we type, for example, 4 different question mark followed by .vcf, it's going to look for all file names that contain exactly 4 characters and that end with .vcf. It's not going to consider files that are composed of 10 different characters followed by VCF, for example. Here, if I use, for example, ABC between brackets followed by star. This will mean that we are looking for file names that begin by either A, B, or C, followed by any other character. So it won't consider any file that starts with letter X or Y or wherever. If you use this sign, like upper between brackets, it's going to look for any file name that begins with an upper case. Yeah, this is an example of a character class, so it should begin with an uppercase and followed by any number of characters. Now I'm going to ask you, so we saw how we can create our own files using text editors. You created some files with Nano, you were able to view their content, etc. But when you are doing some bioinformatics tasks, sometimes you cannot create your own files. You need to upload your files, download your files from some web databases, or you need to copy files from a server or wherever. So you can still use the cp command. You can still open a text editor and use the copy paste to copy a content of your file. But there are some commands that allow you to download packages from files from the web. Like, let's say we would like to download the FASTA file that is available in Ensemble or in any other database. You can use the wget command that stands for webget. So it's a command line utility to download files over a network. It does support HTTP, HTTPS, and FTP protocols. And the syntax is very simple. You can use wget followed by some options if you need to, and then specify the URL of the file you would like to get a local copy of it. wget is also very useful when it comes to internet connectivity issues. So it's going to keep trying to download your file, and there are some options that you can also use to ask the wget to continue downloading from the last location, the last point that it did stop in. So I'm going to ask you right now to move to the directory genomics and to get this FASTA file, which is a FASTA of the Plasmodium falciparum that we are going to get from Plasmodb database. Just to give you a sense of a big file and how we can visualize its content. So again, you can check the different options of the wget command by typing man wget, of course. And we are going to copy this URL that we are going to put into our terminal to download. That's it for this session. We are going to use these few minutes left in my video to show you some examples with the terminal. I'm going to copy the URL, done, and then go into my terminal. I asked you to move to genomics directory. So I'm going to do that starting from the root. I'm specifying the absolute path this time. So this is my absolute path. My home directory is located under users, and this is my username. And then I'm moving to IBT 2017 and then genomics. Genomics is empty until now. So I just cleared my my screen, and we are going to type the command again. So it's wget. I just did it before recording. Let's do wget and the link that we just copied. It might take few minutes depending on your internet connectivity, but now it has been downloaded. As you can see here, it's 100% done. And if we do ls -l, we can see that we have the file that has been already created. I myself did it twice, so I created two different copies of it. So we can view the content. I'm going to delete one of the copies because we don't need it. Okay, so I used ls. It's not the right command to delete. It's rm that allows me to delete. So I deleted that. I have only one file. So if we would like to view the content of the file, remember we can use the more command. You can always use the tab to complete the name. And as you can see here, I have a full screen of text. It's the first page of my file. If I want to move down, I can hit the spacebar and it's going to allow me to move down. Remember that it's also the same thing when you use the less command. So I'm going to use less, and it's displaying my content. And always remember that the difference between less and more is that with less you can scroll up and down, but with more, once you scroll down, you cannot go back in your text file. So I'm going to quit the less by hitting Q. Sorry. I just wanted you to also try, keep trying some other commands that we just saw. Let's try, for example, the head with this same file, and as you can see here, it's displaying only the 10 first lines of the file. It's not displaying the full file because it does contain more than 10 lines. Of course, if you would like to visualize only the first two lines, you can specify the option -n followed by 2 to display only the first two lines. Same with tail. And if you try cat, you will be able to see that it does not display the full file. You will be able to visualize only the last part of the file. So that's it for today. Once again, please keep practicing the different commands that we have been through. I hope that you will be enjoying that. Yeah, it's really very important to practice and practice again, because we will be seeing more commands, and we will try to start writing bash scripts next time.